Okay, welcome everybody. Usually I do a stream on Saturday where we take stuff apart, but inspired by Not Then, I'm going to try and do a CTF. And this is a CTF, you can see it, let me show the desk cam. This board and was made by Hardware IO and NIO, and this is a board that I got in 2000 something, 17 I think, and I never looked at it. I tried it on an earlier stream, but I could not get canbus to work, so I gave it up and I thought it was unpopulated. But Xavier said the lights are blinking. Yeah, how can you blink lights if there's no firmware? So the stupid me. So we're going to try it all over. Last time I soldered Dupont wires to the cable, so I made a little oopsie, and maybe I can show you on this view, the microscope, what I did to solve it. So I soldered in pin header to it on the side, and I used to rework wires to connect the 120 ohm resistor to the pins itself. With me today is a special guest, Ian, and I met Ian only a day ago.
Is that good or bad?
It feels like forever, and I'm so grateful for having him on the stream. And hey, Jan Willem, yeah. See if we can have some fun together. So no promises at all. We're just going to do whatever we do for figuring these things out. And Ian, can you tell a bit about yourself for people that don't know you?
If you have been to any of the conferences in the UK in the last 2 years, this year doesn't really count, but I now run the car hacking village in the UK. I also help out with the car hacking village in DEF CON. I've spoke at quite a few conferences in the UK, Europe, and around the world. My day job is sort of network admin, network security type stuff, architect, but hoping to move towards the automotive security stuff, but that's still work in progress. But yep, it's cool to be here. Hopefully I can help. And I don't break anything, but I can't guarantee. I will warn you though, you hack your own car at your own risk, because it's very likely you will break it. If you ever meet a car hacker that hasn't bricked his own car, he's either not been trying hard enough or he's lying. Okay. I made my Jaguar XE lose its gearbox by just plugging in at the wrong bus speed. Yeah, that was a bit of touching cloth moment, in that it was like, oops, I think I broke it. Turn it off, turn it back on, still can't find gearbox. Okay, now what? Get the diagnostics tool out. Dead short on canbus. Reset messages. No, still can't reset them, because that my diagnostic tool can only reset the first ECU, which is not normally the transmission ECU. So bugger. So disconnect the battery. Okay, disconnect the battery, put it back on, get back in the car, still lit up like a Christmas tree, cannot find gearbox.
Ouch.
Okay, yeah, it's a 40 grand car. At this moment, I'm thinking, ouch, how am I going to get it to the garage? So at that point, I decided to disconnect the battery for a longer period of time, about 20 minutes. After doing that, yep, drain the capacitors, make it lose any kind of memory, what it's got in there, plugged it back in, got in it, turned the ignition on, no error messages, found the gearbox. Started it just to make sure everything's okay. It gets better. It gets better. Started it to make sure everything is okay, and yep, it starts fine. At that point, it was about 11 o'clock at night, so I'm thinking I'm going to bed because I really don't want to try and break it anymore. Next morning, I go to drive out the driveway to go to work, put my foot down. My Jaguar XE had the 8-speed ZF gearbox, which learns your driving style. It'd forgotten how to change gear. It took 3.5 weeks to learn how to change gear. Very nice. Stupid thing was, 6 weeks later, I did exactly the same thing again, but I knew how to fix it that time. People were like, "Why didn't you record it?" It's like, I'm not going to record such a cock up, because if that gets out into the proper bloody public domain, and Jaguar will get wind that I broke one of their cars very badly.
Yeah.
Yeah, it's not a good idea.
Warranty void.
Yeah, but you learn from your mistakes.
Yeah. But this was
If you,
merely a speed thing?
yeah, all I did was I make my own CAN adapters and things,
Yeah.
and one of them I programmed to be 125K board,
Yeah.
to do some stuff with an instrument cluster. Problem is, your OBD2 port is 500K. So when you plug it in at the wrong speed, it thinks, oh bugger, it's got us dead short, and then just goes mental, which is what the gearbox did.
Okay.
I did actually ask the bloke from ZF what happened, and he was like, well, I don't know, but I think you screwed it, but you got it back, so does it matter? It's like, no, but really, it shouldn't do that. But life goes on.
But the sending stuff over a different baud rate will probably create obfuscated commands of some sort.
It basically lost the plot, because the way CAN works, everything has to agree that it's received it before
Okay.
it'll actually acknowledge the CAN traffic has been received.
Yeah.
And it won't cause an error frame and try and transmit it again. So if it's at a different speed, it will never actually receive it. So it all just went a bit oops. But yeah, fixed it. But yeah, CAN has its own quirks and idiosyncrasies and things.
Okay.
And yeah, it's fun.
This is you learn some experience.
Yeah. The other thing you've got to remember sometimes is, if you're doing CAN between just two devices, you may need a terminator at both ends, which is what I was chatting with you about earlier in the day.
Yeah. I got my resistor boxes. So let's get one on. Jan Willem is in the chat, and he said, we've met. You have the car in the box, right? He was probably next to you with the lockpicking table.
Probably.
Doing the safe vault locks.
Nice.
Okay, so what I usually do, and correct me if you have other ideas about it. So what I did is I fired up a Kali VM, and I fired up let me show it, a Raspberry Pi with a con shield on it. So this is the RS485 con shield that has like connectors for AB. Let me get the proper one, microscope. So this AB for RS485 and low high for con. So it can either have like the screw terminals, or use DuPont to wire those. So this is something that we can use that is physically other than virtually, as my experience with virtual and USB connectors is not that great. Don't know if you have other experiences.
They have their moments.
They have their moments.
One of mine's having a bit. One of mine's having a bit of a thick one at the moment. I don't know why. It may be that I need to play around with the cabling.
Jan Willem saying, does the badge only do COM, or are there CTFs as well? Actually, we don't have any clue. There's no documentation about the badge, so we need to start from scratch. And the only thing that I know is there are 20 pins on the side. So I need to make this a little bit more clear. So SV1 and SV2, and they have each 20 pins. And on the board itself is an STM. And I already started. I can dig it, but I don't want to. So what I usually do when I start these kind of challenges, and also my work, is take pictures. So take pictures of the device when it is still closed. Take pictures of the outside, any of the markings that is on there, how the pins are connected. So what I did is I created a OneNote, which is on my other screen. This is it. So what I did is I already noted like the 2 IP addresses that I use for my Raspberry Pi 0. So Pi 0 with the COM connector, and for my VM. So what I'm now going to do is take a look at the yeah, where is it? The microscope view, and here's a controller, and this controller is an STM32. So this board, so board has an STM32 F002 CBT6. So I want to have a data sheet of that one. Open up a new window. So STM C72CB, yeah. Maybe, oh, download datasheet, how convenient. And this has some information. And usually if you scroll just, yeah, like page or 10 or 15, you will have like an overview of the different packages that you run into, and can be either, and now let me first create a snapshot, start snipping tool. Hope this works and not crash the entire thing like it did the last time. And did so again. Are you still new?
I'm still here.
No, this works. So I can snap this. Yeah, works. So now I can make a sniplet of the device. So go back to window view. So this is the picture of the one chip, and there's another one as well. So go back to the microscope view. That's this one. And this is an MCP2551E. And you already knew what it was when I showed you the board, even without an up close.
It's a 5-volt CAN transceiver, not a CAN controller.
Okay.
The STM32 has a CAN controller already built in hardware, which actually, if you want to have some fun,
yeah,
you can bit bang that port rather than use the CAN controller and emulate CAN traffic and make it do things it shouldn't do. There is
which is prevented if you use it via the CAN bus itself, or
if you use the CAN controller inbuilt, there is some fuzzy logic inside that won't allow you to do certain things.
Okay.
But there is quite a good video on CAN errors and things by a chap called Dr. Ken Tyndall.
Yeah.
He's probably the CANbus Jesus or CANbus guru. Look him up if you are interested in car hacking stuff.
CANbus Jesus?
He's not. I refer to him as that, but yeah, he's pretty shit hot with it. He's actually,
what's his name?
Ken Tyndall.
Ken
Tindell. Tindell.
Oh, okay. Yeah. So
you got him. He's on Twitter.
Okay.
And he's made a toolbox that runs around on an STM32 type derived chip, I think, that will do some funny stuff. As in, you can make one ECU on the bus see one packet and another ECU see a completely different packet just by timing things correctly, which is a bit sort of funky. But sorry, I'm just trying to get my own CAN hardware running, so I can at least try and talk you through some commands.
Yeah.
when we get to.
So in the data sheet, for people that are not familiar with data sheets, there's like different packages. So you have the BGA, which is like balls underneath the device, and you also have like the SMD or the pin through hole and different forms. So what I need to do is match the board that I have, which has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 times 4 is 48 pins underneath. So I need the LQ, this one. Can I somehow snap this? For some reason, let's try this new tool. New.
Oh, it's working now.
Yeah. So new. Take this out. So this is this one. And can I somehow link the datasheet itself? Copy. And this is another one. Don't know how important it is to have the datasheet of this one. MCP2551E.
If you look at the chip how it is at the moment, I think the 2 pins at the top are the CAN out.
Yeah.
Which go off to your DuPont pins, and if you look underneath, the pin out is the one on the opposite side, the one on the left, and the one on the right is the data in and data out. Most CAN transceivers follow the same sort of layout, which is quite handy because you can basically swap them in and out quite easily.
Oh, okay. Universal setup for.
You get different ones with different sort of from different manufacturers. Some have some odd pins for standby and sleep and things.
Yeah.
There are a couple that are 3 volt rather than 5 volt, but most are actually 5 volt transceivers. This one is probably a 5 volt transceiver, if I remember rightly. In that, I think only Texas Instruments do the 3 volt one.
So let me see. Suitable for 12 volt, 24 volt systems. Yeah, 5 volt, 4.5 and 5.5 volt. I'm not showing the correct one. It's like happening the entire time. Windows View, so 4.5 and 5 volt. As an answer to your question. So this means, looking at the microscope, that there's a couple of pins. Create an extra one. So pin out. This is which one? SV2. That's 1, 2, 3, 4, 5, 6, 7. And these are, where are you? 2019, 18. So 18 is a CAN, and 17 is a CAN. And
so you have to make sure you get them the right way around, though. Otherwise, it doesn't work.
Okay. Any what will happen if you connect them the wrong way? Will it die or just don't work?
It won't die. It will just not work.
Okay.
It just doesn't do anything.
So if I look at the chip itself, and I'll go back to the second window, it has the dot on the left, so it is rotated. Let's rotate this the same way. Rotate to the left. So it is the most right one is the can low, and the most left one is the can high. So right one is the can low, and this is the can high. Is that correct?
Yep.
Low and high, yeah. So we figured this one out. Do we need a ground pin? Is that important for canbus?
You don't need to have ground for CAN.
Okay.
Because it's differential signal.
Yeah.
Which basically means it works on the voltage difference between the two. There's normally a floating voltage in the middle, and normally starts at about sort of 2.5 volts, and then the low pin will go down by about 1.5 volts.
Yeah.
The high pin will go up by about 1.5 volts, and that is how it knows the difference.
Okay, cool. So I have a cable, and a micro USB cable. So plugging it in, listening for the magic beep. And there's no magic beep here. So let's look at the device manager. Device manager.
Some of the STM stuff, I think you have to actually install specific drivers.
Yeah, but then it will show up as unknown, right?
Yep, should do, yeah.
So unplug the cable just now, replug it again, does not do anything. So this looks like it is made for powering the board and not fanning out a serial port, for instance, or something else that might be part of the challenge.
Let me have a look at one of my STM boards. I
There
know the STM32 you normally have to actually program via J-Link. You need a program via J-Link. So I have this one here.
Okay, I have this one. Like one of the
this is just a board I've got.
Oh, okay, yeah.
It's not got CAN on it, but it will have at some point. But
yeah,
it was bought to get some software put on at an event last year, and by the time I'd actually realised where it was and sorted it out, the chap had left. It was like bugger.
So what we can
you got a flashing light.
I got a flashing light. So like observations like 1, no new device, flashing light, lights, red, green. It's 2 different LEDs. Where is the LED itself? Yeah, and red is more bright than the green one, but it's like okay.
Okay, yeah.
So there's no new device, and we have flashing lights. Boot 0 needs a jumper to ground or VCC to run an alternative bootloader. There is a jumper here. So if I look here, there's a GP1. You need to reset the device after you set the jumper. So what I can do is look for a jumper somehow.
You can either find a jumper or short the 2 pins by just squeezing them together.
I'll find a jumper. I caused enough damage. I have a jumper. Okay. So I'm connecting it. still here.
Or you could use a female to female DuPont cable.
The same, yeah. I have a female to female, yeah, smart one. So I'm. Do I need to reset it?
You'd need to power it off and power it back
Okay,
on.
yeah. It's power off, power on. Hey,
And what's your
haha!
device manager?
I get a STM bootloader. So unknown.
Yeah, but we don't want to flash it with something else until
No,
we've
no,
actually
no.
checked it.
We don't. But now we know what the JP1 is for. So
Yep.
JP1 is turn STM32 into bootloader / DFU mode. So let's look at, so create some evidence, device manager. And now I indeed have a bootloader that is not populated yet as it requires drivers. So let's create a snippet here. Okay. Someone says in the chat, it was weird to hear a Windows sound coming from my Mac. Yeah, can imagine. So let's remove this one and reboot it again. Yeah, I have the blinking light again. So we discovered another thing. And now, are we? What would you suggest to be the next step?
If it's got CAN on it, I would attach it to your other CAN device and see whether we can see anything from there.
Okay. So I have this one, and can I see if this one already features a 120 ohm? I see a 1-to-1. Let me get, where's my microscope view? So there's a 1-to-1 here. That's between L and H. So how can I use this bus itself? Will it have like a? So I am.
If you want to check to see whether the terminator is actually in use, put a multimeter across low and high.
With the power off?
See whether, with the power off.
Okay.
And you should get 120 ohms.
Okay, we can do that.
Between the two.
So let's first gracefully shut the device down. So sudo -i.
You can do it while it's live. It doesn't actually matter.
Yeah. Okay. So get myself a female cable. So it's like a DuPont, cool different colors, and connect these two to H and L. And now I have a male cable. If I unpack this one, okay. So let me get my box again. So I have some crocodile clamps. Get my.
I've got loads of them boxes as well.
Yeah, you can never have enough boxes. So set my multimeter to ohm. Kilo ohm, mega ohm. Oh, it's auto select. So connect one wire.
That chip that is just below your
sorry.
The chip under your microscope at the moment is VP230. That's a 3.3 volt CAN transceiver made by our friends at Texas Instruments.
Okay, so this is not going to work since they have a different voltage. or
no,
doesn't
it's
matter?
fine. No, it doesn't matter.
Oh,
It's just it's
the
the
receiving
I/O
end.
voltage.
Ah, yeah. Okay, clear. Okay, so connect one cable and connect the other. Jan Willem, the USB in the new STM are very useful. You can do lots. You can do loads of interesting stuff like. I need to scroll this a little bit. Like this bootloader, but also virtual UART debugger and many more. If it was locked, I would have linked it on the doc on how to dump it. Okay. So connect this one, and it's stating 1.27 ohm. I show it here somehow. So this one.
So what? That's 100. That's about right. It's 130ish ohms.
Yeah.
That's fine. Yep, that'll work.
Cool.
So you should be able to then connect can high together, and then can low together.
Okay.
On your Pi board and your hardware I/O board.
I just bought it and I never tried it. It's always fun to do these things first in in a live stream before trying them yourself. Have the full experience. So let's go back to the drawing that we made, the pin out. So there's a can high, which is blue, and this is connected. So let's first take the can low then, because that's closer to it, which is on this pin, can low, and the one next to it is can high. Okay. So now now they are connected together. Can high, can low. So go back to the Raspberry Pi putty screen. Where are you? Raspberry Pi. So here it is. So how would this show up? Is it like a serial port of some sort? Like
no.
Okay.
Have you installed added the relevant DTC files on your config.txt?
VI, etc.
It's boot /
boot,
config.
yeah. Boot config.txt.
Yeah.
And this requires like a setting for having the correct. I see a MCP 2515.
Correct. I'm going to send you a link over the Zoom chat.
Okay.
The only thing is, I don't know which pin the interrupt is configured on for that board you've got. So unless you've got something that tells you what pin it's on.
I think I already configured it according to the. So this is a RS485 Con Shield by Waveshare.
Yep.
And this is actually the second one. So I need to go back to the microscope view. And this has a crystal on top. So there's two versions. There's one with a. So this is not the one. Raspberry Pi.
12 megahertz.
Yeah.
Normally 8 or 16.
Okay.
12 may work. But...
Can shield. Can head, I think. Okay, so there's one with the 8 megahertz one, and one with the 12 megahertz, and the one with the 12 megahertz should be set. So let's copy this in the OneNote as well. Pi 0 can head. There's this one, and where are you? Okay, and this requires
Okay, interrupts pin 25.
okay.
So that text I sent you on the Zoom chat,
Yeah, this
you
one.
need those two bottom lines and change the interrupt to say 25, and also change the oscillator to be 12 million, not 8 million.
It is already set MCP 25, so it is set. I did not show the correct one. Again, this will be my total. So this already includes this statement, and it is put here. So MCP 2515 oscillator, 12 megahertz, interrupt 25, SPI max frequency is 2 million. Okay.
Okay. Yep. Does it tell you to do the DT overlay equals SPI BCM 2835 or not? No. Okay. I think the instructions that I've got are for a normal Pi, not a Pi 0. So
okay. So so if I look here at config.txt, so this one should be added as well. Did I already add it? DTI overlay. Well, okay. So added it as well. Reboot. Okay.
And if you do demessage after it reboots,
Yeah.
you should see something related to MCP 2515 in the demessage.
Yeah. Let's copy this to the OneNote as well.
But that link tells you how to use the really cheap CAN module that you've already got on your desk.
Yeah.
With a normal Pi with a bit of changing because it's a 3.3 volt or 5 volt transceiver.
I need to switch my camera as I did not make the SSH persistent. Okay. So okay. So switch back to the microscope view. You can do it. sudo -i system ctl enable ssh.
The easy way to do that on a Pi is put a file on the boot partition with the name of SSH.
Oh, okay.
And
oh, cool.
it automatically turns it on for you.
Nice. Did not know that.
All of my Pis are completely headless.
Oh, okay.
I have one set up as mail server, one set up as a Pi hole, one
Yeah.
set up as a network management box, one set up for my Unify wireless.
Nice.
I had to completely rebuild my firewall at the weekend because my Cisco ASA decided to kill itself.
Yeah.
So I had to put a pfSense box in. Not fun.
Yeah. I just bought the Turing Pi. It's going to be delivered in either November or December. So there's like 148 pins of GPIO.
That's the one with 7
7 compute modules, but it's still the tree, so it's slow on due to limitations of the module itself, and also
and the USB bus.
USB bus, and still the 2, not the 3. And next year they will come out with a 4 version as soon as Raspberry Pi comes out with it themselves. Okay, so Pi sudo -i the message, and this should have an.
If you do pipe grep MCP, you should see something in there. Can you swap your main screen?
Yeah, that's that's not the last time that you said that to me. Yeah, successfully initialized.
Cool. Now, if you go back to that other link that I sent you,
yeah, this one.
It should. I'm looking at the actual Twitch stream, so I'm looking at in the past.
Yeah.
In there should be the command just below.
Comutils.
Have you installed canutils yet or not?
I have no clue.
Okay, you can.
I might have.
Canutil. It won't matter if you do it again.
I did. It's installed.
It will just go. No, you've already got them.
Yeah.
Thank you very much. Now, in theory.
Yes, this is. I'm using. What is the name of the thing again? Yeah, like a USB HDMI grabber, 2 actually. So one for the Pi and the other one for the microscope, and one for the GoPro. Okay. Yeah, if I go to.
Now, if you scroll down a bit further in that website, it will tell you there's a IP link set or something command you need to run.
Okay. Do I need to set it to 125K?
It may be 125K, it may be 500K. That's where we play the game and find out.
Yeah. ifconfig. So scroll up. I have a CAN now that is up and is configured to 125K.
Okay, so if you now do can dump can 0.
Can dump can 0. I'm like remote hands now.
Yeah. Does it actually dump with a P on the end?
Yeah, that's the second one.
Okay, you're not getting anything. It may be 500K.
Okay.
But you're going to have to do IP link set down first before you try and do it back to 500K.
Link set con 0 down. Yeah, and so make this into a 500 and do the con dump again. No.
If you can see, yeah, you should be able to do can dump can 0. If you can see my screen, I have a can adapt. I have a instrument cluster. And if I send a certain CAN bit of traffic,
Let me share your screen. Yeah.
you should see the speed
Oh
go up.
yeah, cool.
So it's
That's just by can dump.
that's not can dump, can send.
Oh, okay, yeah.
Can dump will just show you what's coming off the bus.
Yeah. It's like Wireshocking, right?
Yes. I don't have GUIs on any of my devices, so Wireshark would be a bit academic.
Yeah, T-Shark. Not doing anything, but I have to admit that I already connected an oscilloscope to it, and I did not see any data coming out of these ports.
Okay.
What I can do is like reset the device.
You could try that because see whether it starts sending.
Okay. No, that did not. Is this the correct one? Yeah. No, that did not do anything.
You can try sending random data to see whether it responds.
Sure.
If you type can gen,
Yeah.
space can 0,
Yeah.
space minus VV.
DV. Delta
VV.
Victor.
No, Victor Victor.
Yeah.
It basically does it verbose and shows you what's actually happening.
Yeah.
Do you want to switch camera?
Yeah, sure.
Or view.
Window view. Yeah. So I can do it again. No buffer space available.
That means the other end is not actually using CAN.
Okay.
Because normally it's either it's not using CAN or it's you're at the wrong bus speed.
Okay.
So what happens is if it cannot get an acknowledgement from the other device on the bus,
yeah,
it basically goes, oh, I don't know what to do with this because I'm going to keep retrying.
Yeah.
And then it runs out of buffer space.
Okay.
And the pain in the arse that is this module on this thing is I think the only way to get it back is either you can try doing IP link down.
Yeah.
Try that. You could and then bring it back up again. It may work, it may not. If you then do can 0 again.
Yeah.
And see what happens.
I was able to do a larger amount than I had before, but it's still stopping.
Okay, try running it at 1 meg as opposed to 500K.
Yeah. Nope.
Yeah. No. I don't think that's doing anything CAN related.
No.
Especially if you scoped it and you're not seeing anything.
Sorry, especially if I'm?
You used an oscilloscope to see what you can see.
Yeah, I can try it again. See. It's on portable power. Input and connect this one to male cables. Okay. So disconnect this one and connect these. Switch back to desk cam. I do see stuff.
Is it on the can pin?
This is on both can pins.
Shut down the Pi to see whether that makes any difference.
No, the Pi is already disconnected.
Oh, okay.
So
it's doing something, but it's a bit too regular to be can.
Yeah, I can disconnect it and reconnect it.
Try it.
Okay. How do you connect it? It's like
What frequency is that?
50 milliseconds. So if I connect it again.
That's weird. It started high and then went low, and then nothing's happened. Is that picking up noise?
Yeah, it looks like.
What you may have to do is twist the two can high, can low pins, because normally it's a twisted pair.
Okay. Yeah. Yeah, this is the hardware I/O thing. Okay. So I twisted this one. Now I need to twist the other side as well. Let me.
Are you using the scope between can high and can low?
Yeah.
Okay, yeah, that should.
Let me.
You should still see voltage changes.
Get another one. Let me get another probe. Maybe this is like a it's like a really cheap probe that has crocodile clamps. So this is like an oscilloscope clamp that might solve stuff. First twist these cables. It's like now we're debugging multiple things at the same time, like the tools and the things itself. So having proper gear is always a plus one. Although I do like to solve stuff ghetto style.
It works, it works.
Yeah, if it works, it works. So connect one, connect two. So this looks like a stable signal. Let's disconnect it and connect it again.
There's data, well, there was some data there and then it stopped. Can you scope it with it connected to the Pi?
Sure. Then I need to put a breadboard in the middle. So that requires a male-female cable, or a male and a female. Yeah. So. Okay. Can I do it without twisting it, or do I need to twist it as well?
It's probably better to twist it, just so you're not picking up the 50 hertz hum from your mains.
Yeah. Then I'll twist it. So 1 and 2, and twist the other ones as well. So the H. Oh, that's good. So so the let me go back to my notes. Pin out. So the one on the right of the board is the yellow one. So low is yellow connected to red, and the other one, so that's the and low, is connected to the black one, which is connected to the green one. Just to make it a little bit more complicated. So the red one is connected to the green one, and this one is connected to the other one. So now they are connected. Now I need to male cables to connect the oscilloscope. So connect this one and this one, and connect it to one pin and the other. This looks like traffic. Sorry. Nope.
Oh, that looks like it's doing something.
Yeah.
Try can dump can zero now.
Can dump can 0, switch to the other screen, or do you want to see the oscilloscope?
Screen,
Okay.
if anything's coming out.
Yeah. Can dump can 0.
If you do ifconfig, are you seeing any data being received?
Let me check. ifconfig.
You can put can 0 at the end.
No.
Cancel first.
Cancel first.
Yeah, ifconfig and then can 0. So you've two transmit errors.
Yeah.
And 0 receive errors.
Yeah.
Okay. Let me have a look. So we've tried 1 meg. We've tried half a meg.
Yeah.
We've tried have we tried 250?
Let's see. History. What am I doing? History. What was the command again? ifconfig, right?
You have to do IP link can 0 down.
IP. No, we did not.
Uh,
250.
Nope.
I don't see anything on the oscilloscope anymore.
That's strange.
Or
maybe we were. Maybe we were on the right speed.
Sorry.
Maybe we were on the right speed.
Let's so IP link set com 0 down. This is 250. Did not work. 125.
Is the scope come back to doing anything meaningful?
No. 500. What would be a correct time base for this?
I'm actually just trying to work that one out. Let me Google.
I see data when it's on 125.
Okay.
As when I'm broadcasting on 125.
Yeah. Might sound stupid. Try swapping the wires around on one of them.
Yeah.
Just we may have read the schematic wrong.
Yeah, I just plugged them in incorrectly. Okay. No, same behavior.
Try canned up, can zero.
Yeah, okay. No.
If you measure the resistance between the two can high and can low,
On the
that should be either end of the bus. It doesn't really matter. It should show 60 ohms.
Okay. Where are my crocodile clamps? So set this one to ohm, select ohm. So this is the one wire. And this is the second one. What's the other
Definitely
one?
something periodic coming off there.
Sorry?
There's definitely something periodic coming off that on the scope.
0 ohm.
Shouldn't have 0. Try without the scope connected.
Yeah, the scope is disconnected. I connected them directly to the board.
Yeah.
So let me remove this one. So what am I connecting to now? Yeah. So I'm now connected to the CAN head.
Yeah.
And that's 0 volt. And if I connect to the
No, the resistance, not the voltage.
Yeah, the resistance. So the resistance of the exercise board is 122.
Yeah.
And the resistance of the other one can high, can low. So it's now it's 0 volt. Is this wire maybe broken? Because we tested this before, right? On the Pi itself.
Yes, we did.
So why isn't this working then? like a this is so odd. So we connect them to this one. Why isn't this range? Oh, is this maybe because I'm dumping right now?
Shouldn't be.
Let's kill
It
the.
should still be able to measure the resistance.
So range. Let's disconnect the cable. So set this to ohm and connect it again. No. Down. As soon as I shut it down, it will become 120.
Really?
Yeah. So
if you wire the two together, what's the resistance then?
okay.
With
So
it shut down.
With it shut down. So now I'm first checking the there's 120 ohms for connecting the CTF board, and now connecting the other one as well, and now it's 61 ohm.
Yep, which is what it should be.
Yeah.
So we've got the right resistance.
Yeah.
And we are sort of seeing data when it's 125. There is the instructions for the wave share can hat.
Yeah.
Let me just have a look.
Let's connect the oscilloscope as well.
So you might want to remove that extra line I gave you, see whether that actually makes any difference.
Okay, yeah, sure.
Because it doesn't actually mention that line anywhere.
No. VI boot config. This one. And slash HDMI.
Let me just
reboot.
You've got SPI on, haven't you? Yes, you have.
Is that score high impedance or 50 terminated?
Neither.
Neither. If 50 ohm, then you load the lines with an extra resistor.
Bugger. Yeah. Measuring things can affect the signal. Yeah, thanks, mate.
Yeah. Did you find anything on correct setting for the oscilloscope?
No, not really.
Okay.
There was a thing for Keysight, but it didn't actually give you any information about speed.
Okay. Headless. Sudo -i and set the con 125, con dump, con 0.
Okay. Nothing. Try can gen again.
Yeah. Can gen. Okay. No, same stuff.
Hmm. Oh. Okay.
What?
Yep. That I saw it coming through, but it was you sending the stuff,
yeah.
not it sending.
I set it to 10 milliseconds now. Yeah.
There's something definitely happening there. Have you got one of the Saley logic type things?
Logic analyzer.
Yeah.
Yeah. Let me see.
You can plug the 2 different channels into that. You may need ground. And you should be able to see what's going on, and it might even be able to decode it for you if it reads it as correct can.
Yeah. Okay. That's a good idea. I do not have a Slaya, but I like a crappy one.
I've got this crappy Chinese one. It works.
Okay. And I have a slightly better one. So let's first set my multimeter to Wi-Fi. Where are you? Come on. This one. So connecting it to the ground and the ground. So we found a ground pin. Pin out. So copy. So which is actually pin 20, and this is ground. So this is female, so I need a female cable. Yeah, take a green one then. So this is ground. Let's see if I have pulse view installed. Yeah, looks like it. And do I have? Oh.
Before you do that, do you want to try it with just seeing if we can see any data? Now we've changed those settings in the boot.config.
Data where?
On the canbus, on the Pi, because we've just changed. Did we do that?
Yeah,
no,
we did that.
We
so
checked it.
Con gen
No.
and con
Yep.
can dump. I need to look for a dongle that I have somewhere. Where are you? Hold on, I'm going to grab some stuff from next door. Audio will be probably.
Yep.
should be back again. I have a dongle. Now I need a proper cable. So, do I have a mini USB somewhere? This is a mini USB. So connect it. Connect it to the dongle. And now this one isn't working, so I need to start it again. Pulse view. Where are we? And it will tell me that it found the thing itself. So connect this one to one to the ground. So ground. And the other two connected to channel 1 and 0. Where are you? So it's connected. Let's first see if we have some data. So canbus is 1 megahertz, 2 megahertz.
Well, it depends what you've got it currently set to.
I don't know.
I never know what to set the sampling frequency at, because it's sometimes it works, sometimes it doesn't. It's
yeah,
just
it depends on the protocol, right? So
yeah.
it's set to 8 megahertz, so it must be for you need 8 mega samples for every second. So let's do 15 mega. You can set it higher, but since PulseView is loading everything in memory, it will be crappy. So
Yeah.
run this and disconnect the. Oh, it's already disconnected. So connect it. So it is connected at the end. Maybe I need to run it again or set this a little bit higher, set it to 100. So run. Stop. So let's scroll down. I see no data at all. Yeah, it's all
Try
line.
zooming in.
Sorry? Yeah,
Try zooming in.
I can zoom in, but like there's no data here. So what I can do is I can make the sampling speed higher. Let's set it to 24.
Yeah.
Because maybe we lose something. Run it again. And no, nothing there. So to test like a sanity check, connect these ones to where's my ground on a Pi?
If you've got a steady hand, you might be able to probe the CAN transceiver on the other side.
For the okay, on the device itself.
Yes.
Okay. I have something for a steady hand somewhere. Where are you? Ah, here you are. So I need to disconnect this first. And I have some clip-ons. Okay, what are the pins? So this needs to go to 20.
It's the outer pins on the opposite side of
Okay.
where the resistor is.
Okay. So let's amplify my site. Where are here it is, and where is my microscope? Yeah. So it is here somewhere. Here. Zoom and
So pin 1 and pin 4 should be the data coming from the microcontroller.
okay.
LED's not flashing.
No, it's off.
Oh, okay.
Let's so this is one, and now the other. Untwisting the cables, otherwise I won't make it. So this one, where are you? It's the short one. So need to do always saying I'm getting too old for this, but so let me see how they are connected. Yeah, looks okay.
Yep.
Connect this one to ground. Start the second, where is it? Window view. So the other one. Insert this one and do a run.
Oh, excuse me.
Bless you.
There's no LED flashing. So have you turned it on?
Oh, there's this connector that needs a socket as well. I hope this is not what I did wrong the last time. So let's switch this back to 8 megahertz then. So press run. Insert this one. Oh, run. Touch the wrong cable. Amazing open source software. Pulse view. So set this one to 6 and set this one to 100. Run. Disconnect. Connect. No. Now what I can do is make like a longer sample. Run. Maybe once every so much time something will happen. No, nothing.
Are those LEDs across the those two CAN ports or not?
Sorry?
Or the LED, where are the LEDs wired back to?
Yeah, let's find out. Okay, this is not working. One thing that I want to try. Oh, let's first see where they are. Yeah, since this is a CTF challenge, you could probe the LED so we can actually get some data.
True. Yes.
True. Am I able to? Yeah. Go to microscope view. So where's the LED? The LED is connected to something underneath, and this is like a puzzle. So they created a lot of pass-throughs. So like for the effect.
Yeah.
So what I can do is uh, it's getting messy here. Connect this one. This one. So we want to know where the LED is heading to. So this is, I expect somewhere on the STM.
Yeah.
So
One side should be, one side will probably be ground. The other
we
side
can test
probably
that.
goes via a resistor.
Use this. Nope. Not connected to ground.
It might be to VCC.
Yeah, don't know where the VCC is yet. So that might be in the bus itself. So which is the thicker pin? Where is it? Is it like this one?
Which
The one on the left?
the one as it's shown in the on the USB port, the one at the top is VCC.
So this one. Okay.
Come on.
Sorry.
Yep.
Okay. So let's connect to this one.
Actually, no, that's ground. Ignore me.
Okay.
One end is VCC, the other end is ground.
Yeah, but if I probe them all,
So,
then it should beep.
yep.
And it does not. So is it this one? This one maybe. But we can see how it is connected to the STM. So one of these pins needs to be connected to the STM. Yeah. So it's a pin on the right somewhere. And I need to focus. So 1, 2. So is it this one? No. This one. So this is bottom. Oh, both pins? No, just the bottom one. So this is on the right side. Let me look at the device itself, port. So this PB12. So PB12 is connected to the right one, and the right one is green. Okay, so PB12. Now I lost the keycap. PB12 is green LED. And while we're at it, let's try the other one. So it's the left one. There's one on the bottom.
32 and 33 are CAN, RX and TX.
So this is the fourth pin. Fourth pin. Where is it? This.
Oh, PA11 and PA12 is the pin name. So it should be halfway down on the right-hand side.
So this is the bottom. So this is, sorry, not showing much. So this is the fourth pin, and the fourth pin is actually connected to this one. Right. One. So this is connected to the fourth pin, which is 1, 2, 3, 4, PA6.
PA6.
6 is the red pin. Red LED.
Okay.
If you look at serial on serial STM, oh, we can Control F. What is it? UART. RX. RX.
Might not be UI, it might be USART.
Yeah, it's USART. Synchronous. So this is USART 4, 2, 3, 3, 3. This is 1.
Cool.
So
1 is the same pins as CAN though.
Is it? No.
No, ready RTS and CTS.
Yeah,
so
correct.
You've got PA9, PA10, which is USART TXRX, and then you've got PA11, which is CAN RX.
Okay. Let's find PA. Let's make a snap again. So this is USART.
PA9 is probably one of those 3 on the right-hand side that have got the vias right next to them.
Hold on. Sorry, the one
On the right-hand side of the chip, there's 3 vias on top of each other.
Right hand side, VS, and this is.
And back to the chip. Yeah, you got 3 vias on top of each other.
Yeah.
So let me have a look.
That's PA.
Okay, no, PA. You got
the
PA 13 is the top one. PA 12, which is one of the CAN ones, is the middle one out of those 3. And PA 11 will be the bottom one of those 3, which should be the other CAN.
Okay. Bless you.
Thank you.
Uh,
What time's your live stream normally on Saturday?
on 10 o'clock. No, same time, 8 o'clock. So 7 o'clock.
Oh, okay. Can't do it this weekend, but maybe in the future I can set my car in the box up and you can have remote access and see whether you can have a play.
Yeah, that would be cool. Let me see. This is 48. Let me get back to this one. Oh. Where's my date sheet? So pin. This is USAR2. There's 2 and 3. And I already sneaked some things earlier. So if I connect this one to another one, and go to the 3rd pin here, and go to one of the corner pins. Where are you? This is connected. This is connected. These 2 should be. Why is this not? This is the black one, is connected to the red one. Oh, no, then it won't work. So if I, yeah, okay. Okay, so bottom left. So bottom left, let's create this snap of this one as well. Where are you? So this is USAR2 RX and TX. And go to the one node. And where are you? Okay, one is enough. So the again, where is it? Stop. On the left, so PA2. PA2 is connected to SV3, which is RX. And if I go to 4, this is connected to PA3. Yes. So PA3. Oh, I need to share my correct one. PA3 is connected to SV 4, which is the TX. So we still have an logic analyzer connected. So let's connect the 2 pins here.
See where we get any serial data.
And see if we can find some serial data. So this is connected now. And now go to...
We're just going to get a drink. Back in
yeah.
a second.
Okay. 200. Have to look at the alternate pin mapping. It is a just as a sanity check, I already checked the ground pin. So where is it? So this is the ground pin. And I have a needle here somewhere. Okay. And the ground pin is the second pin here on the top. So if I go, oh, sorry, you did not see it, but yeah, you have to trust me. The second one is VSS, which is ground. So I know that the pin is the chip is aligned correctly, and it's like the dot on the top left will illustrate that it's connected correctly. So where is my micro USB? So what I'm going to do now is press run and then connect the power. And actually we see some sort of data. Okay, we can stop this, zoom in. Oh. So this shows some data. So let's go to the protocols. So hey, this fancy new view. Decoder, where did they put? Can I just do UART? Ah, cool. Add UART, so it's a UART pin, and I'm using the RX4D0, doesn't really matter, and see if it's 150K. So scroll up a little bit and zoom in. Oh, what am I doing? So these bits are much bigger than these bits, so work our way from the other end. So click here. Don't put the pull up, the up button and the down button, because you will wait forever. So just type the value, and this will say this is a byte and overlaps with this value. So this actually looks okay. But I'm not reading hexadecimal, so set this to ASCII.
Yep.
And see if we get any data. Not that much. What is happening? Parity odd. None. Ah, that helps. Why is it standard on parity odd? So bullshit, congrats you. And this is a line feed OA. And bullshit you, bullshit.
Is that what it's saying?
That's what it's saying. Congrats and bullshit. So so let's connect a serial terminal to it. So I need to measure the voltage first. So connect one to the ground and one to one of the pins, and connect that to my multimeter. Set that to voltage first. So connect one pin and the other.
It's probably 3 volts.
3.259, so 3.3 volt. Yeah, cool. So I'm using an FTDI now. It's like this baby. And I actually got to this via Chrissy Morgan, Swordfish on Twitter. And this one has 1.8 volt, 2.5, 3.3 and 5 volt. And they
Cool.
actually have a galvanically separated one.
So you won't blow your USB port up.
Yeah. So connect this one, and we already knew what the RX and the TX were, but yeah, you can do a YOLO and just connect one, and if it does not work, just swap the wiring. And the next one is TX. So the TX should go to the RX, and the RX is the third one. Is that correct? Yeah, the third one, and this is the fourth one. And now I'm unable to show you because I need to plug it in into my USB hub, which is nearby. So I need to connect to my device manager.
Quickest way to get up device manager, Windows X.
Oh, okay.
And then it's in the list.
Cool. So that's COM8. So connect to PuTTY somewhere. PuTTY. Right click. PuTTY on my other screen. So that's serial 9600 baud. And this is COM8. So let me look what it says. Does not say much. Why is that? Did I make a mistake? It's odd. Maybe I did.
Have you powered it back up?
Yeah, it's powered up. It's twisted. Okay. So it's the other way around. So it's saying bullshit. So what I'm going to do is disconnect the power and connect the power.
Let's see whether anything comes up.
Because it states doing obfuscation, doing bullshit, congrats you. Do you see it?
Yep.
So this is actually something that happens. So let's document it. Serial real 9681 on what was it, SV2 3 and 4, and this is the data that we get. So we have a canbus that is not working. We have a serial port that's telling bullshit. We can put it in.
Canbus looks like it's doing something, but we're not seeing anything on the SAILI.
Yeah.
Which is a bit odd.
Yeah, but it could be that the probes were showing interference. I can do it again on the. Want to do? Try it again.
Try it. See what happens.
Okay.
Well, at least now the SAILI's, we know the Pulsey is working.
Yeah.
Because we've got some.
Yeah, that's a
data.
sanity check. Because data. Yeah. Okay. So I have a ground pin and one of the canvas pins. Is that enough for a reading?
You won't be able to decode it, but it should be able to show something.
Yeah, if I just see pulses, it will be enough, right?
Yep.
So run this one. Where are you? A lot of no data. So this is not working. So connecting it to the other pin. Run.
No, not seeing any translations there either.
No. Jan Willem, do you have the same board as well? He said he dumped the firmware and tells me there's nothing to see here. That's cool. What I could do is measure all the pins to see if there's any pins with like a 303 voltage and add those to the logic analyzer to see if there's anything else.
What if you connect transmit and receive together and just monitor what's going on?
And monitor on the serial port?
Yeah.
Okay. Sure. Oh, where are you? So RX TX ground, and I need to insert this in here. Where are you? Ground. Yeah. Is there a putty here somewhere? Here. No. So putty. Serial COM8 9600. Insert power. Yeah. So you can just connect the CAN high to the CAN low?
No, you shouldn't really do that. But if you connect the serial TX to RX, see if that makes any difference.
Oh, okay, like that. Yeah, you can do that. Okay, so disconnecting this. So add the serial high to low. So it still blinks the same. Let's disconnect it and connect it. It blinks the same. So now check for the CAN bus again.
You can try it.
Okay. Channel 1 and canbus is this one. Okay. And run. No. Why I could not download the firmware they called download to the device download upload from the STM32. Okay. Yep, a green one. Okay. So Jan Willem, JWRM22, also has the same badge, and he dumped the firmware. Yeah, we can try and see if we can dump the firmware using JTAG. Or do you have any other suggestions? Yeah, so sorry, there's not that much CAN here.
No, there isn't.
Yeah, I was hoping to have some fun with that, but
we can have some fun with CAN when the post turns up.
Yeah, thank you for that. So let's look for SWD. So this SWD IO. So create another tab. Add JTAG SWD JTAG. So SWD IO. Where is my snipping tool? New. And add this one. So this is SWIO. And then I need the SW clock. New. This one. And that should be sufficient. So now we need to probe where they fed this, these two. So that's PA13 and PA14. So go back to the board itself. PA13 and PA14 are on the
PA14 is top right.
Yeah.
And PA13 is 3 round.
PA. Oh, okay, yeah. Let's PA13, PA14 devices board. PA14 is here. So need so the top right, and I need another probe. So this is still set to volt. Select Wi-Fi. Yep. So top right. Switch to microscope. Here, top right. Top right fans out on this convenient pin. Okay. So that's 1, 2, 3, 4, 5, 6, 7 from the bottom. 7 from the bottom on SWT2. One, 2, 3, 4, 5, 6, 7, and this is getting messy here. Board PA14, pin out PA14, and PA14 is clock. Okay. CLK, WDCLK. And now the other one is PA15 is on the bottom. And is there a convenient? So that's 1, 2, 3, 4, 14, 3. 1, 2, 3. There's also convenient one. This one.
PA15 is PA15 is at the top.
Oh, it's PA. Oh, sorry. Oh, they are next to each other. Yeah. So 14 and 15 is next to it. So that will be this one then. Yeah. Okay. So there's 1, 2, 3, 4, 5, 6 from the bottom. 1, 2, 3, 4, 5, 6 from the bottom. This is PA15, which is SWDIO. Okay. So now I need to connect a ST link to my VM. So where's my VM? Switch to the second screen. So go USB and set this one to, where are you? ST link. Okay. So there's already a putty connected to that one, Kali. So if I do ls USB, I should be able to see it, and I do. And this one has this, so connect here. Opt install open OCD sudo-i open OCD. Okay. Locate ST link. Update DB. So there are some targets here. So cut one, copy, paste. What is happening? CD user share open OCD scripts targets got st oh, it's not the targets, it's the other one. It's the boards of interface. CD interface. It's interface. Got st link dash v2 dot cfg. What is happening here? Cannot find interface st link. Oh, okay. Got st link st link cfg. Okay. Oh, this is new. They used to have like different interfaces for OpenOCD for the different models, the 1, the 2, the 2.2. But now they seem to have them all combined in one driver. So we need 04A3 and 3748, 3748. So this is in here. So PWD. So this is one. and what is the name? stlink.cfg. And the other one is the target. cd target. And this is an STM. We had that in the
32F078.
32F0. Okay. Oh, and already convenient with an ST-Link. Got source target is deprecated. So you need to use this one. And does it already have the interface accompanied by it? Don't know. Open OCD-C. What is it? Dash F then. Interface ST-Link.cfg. Check the order. F STM32 FOX CFG. Okay, so this is working, but I need to connect it to the device. So I need some wires. And how are they connected? So 1, 2, 3, 4, 5, 6, and 7. So 6 is SWIO. So where's SW? Get it under the microscope. IO is on the right. Yeah. And clock is just above. And then there's a ground pin, 20. And the ground pin is underneath. How convenient. Okay. So connecting the device. So LS USB. Gone. So I need to reconnect it again. Devices USB STM. So again, LS USB. Switch back to the window view. And yeah, we have it again. So open OCD, does not do anything. Now I'm going to power the board, since I decide not to power it over the ST-Link. Because different people have different opinions about it. Okay. Why is this not working? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 6 is connected to Why not? It is set to SWD. Make a mistake. Unable to connect to the target. Oh, okay. It could be that the reset. Is an RST enough to trigger it? That's a question for Killer Geek in the chat. So. IO. So where's the reset? Go back to this one. Yes. Okay. Find RST. Where's the reset pin? Ah, okay. So N reset means no reset, inverted. Okay, so on, okay, it is on the 48 is pin 7. So let's disconnect it again. So pin 7 under the microscope. Where's my mouse? Microscope. So pin 7. So it's 1, 2, 3, 4. 1 from the other side. 1, 2, 3, 4, 5, 6, 7. Hey, there's a convenient little thing next to it. So COM7. It is set to, yeah. Maybe not on this side, but on the other side. So 2, 3, 4, 5. So 5 from the other way around. So that's pin 20. This is ground. 1, 2, 3, 4, 5. This is an RST. So find a female connector. So that's 2, 3, 4, 5, and connect this to an RST on the top. Okay, so connect it again. Now I should configure my Kali to have this permanently installed. It would be even more convenient. Okay, LS USB. We have the STM again, but it won't do anything unless I power it. It is powered. And now start OpenOCD. Nope. Not doing anything. And it is set to SWD. Set to ground. Any other suggestions? People in the chat or Ian?
I've never done this, so
Oh, okay,
this is new for me.
okay. I've done this before, like on Bluetooth glasses, dumping EEPROM. Like there's OpenOCD, which is a piece of software to do JTAG, and you can do it either using the regular JTAG or via a serial wire debug JTAG. And with a simple ST-Link, you can just hook up a few wires to the device, then open OpenOCD. That will create a listening port, and you connect
Yep.
to it via either GDP or via Telnet, and then you can just dump the entire firmware if the correct fuse bits are not set. So
Okay.
it's really a really convenient way of dumping it. Do you still feel up for continuing? Because I can imagine it's getting late.
It's getting a bit late for me.
Yeah, I can imagine.
So
So I don't mind if you want to drop off and continue next time with your stuff on board.
cool.
So thank you very much for all your suggestions, like the stuff and measuring the stuff, like the 120 ohms and the 60, and using the different tools.
It may be worth you at some point setting up another CAN adapter and just setting a known CAN adapter to send stuff to that
Yeah,
Raspberry Pi, just to see whether everything's actually working correctly.
yeah,
Or get to small CAN adapters sending stuff back and forward,
yeah,
and then at least you can see what's going on.
yeah.
When that stuff turns up at the end of the week, you'll have a couple of PCBs to play with.
Yeah, yeah. Tomorrow I should have like the required stuff for these PCBs, so should be all
Yep.
fine. And yeah, that I think that's a good idea. It's always a good idea to first test your testing equipment, like make a test setup to have a sanity check of some sort. But the fact
Yep.
that we're already able to like see serial stuff is a start. So it is
Yep.
populated, and we can do stuff with it. And I think we're just a moment away from getting the firmware dumped, and then yeah, if we're able to do CAN, that would be really cool. So thank you very much, like for
Yep.
all your help. And yeah, it's like I looked on your website. There's got a lot of information on it. It's like very cool stuff. So yeah, we'll keep in contact. Thanks,
Yep.
Ian.
Cool. Cheers, Giles. I'm going to sign out now.
Okay.
Thanks, mate.
Thanks.
Bye.
Bye. Crazy, do you still hear the robotic voice? I saw that my aux was set to a very high level, so it's like probably overmodulating a bit, and I set that back, so it's now in yellow levels, so it should be better now. Still a little bit annoyed that I'm not able to dump the firmware, so let's disconnect it. People, a question: do you still want to continue this stream, or are you fed up with it and let's call it a day? I don't mind continuing, but I'm getting myself a cup of coffee if you want to continue, and if you want to, I suggest you to do the same thing. So yeah, just write in chat if there's someone that still wants to continue, or if you want to stop it and do it another time, it's fine by me as well. So all up to you. Going to bed, yeah, I can imagine. Can you show the OpenOCD code again? Yeah, sure. Like for seeing if I'm doing it correctly, I imagine. So yeah, we could do that too. So if there's people. So what I did is I used the ST-Link. The ST-Link has the correct adapter in it, and I used STM32F0X. And my experience is if that's the incorrect one, it will tell me that the ID correct, and just tell me what ID to look for. So I hope you're able to see it. So I'm going to get some coffee now. So if you want, you can still stay and I'll continue. Or if you want to go to bed and other people will stay, you can continue and watch the stream later. I'll get something to drink and I suggest you to do the same. See you in a bit. Okay. Uh, but it fails to connect before I can get the ID. So Killer Geek, you have the same one as well? So what I was thinking about doing is I still have this Bluetooth device, and I was able to dump the firmware on this earlier, but with a different version of Open OCD. So what I'm about to do is try to do the same thing with this one to see if I'm able to get Open OCD to work, and then work to the batch. I did not use a reset for this, so let's put it under the microscope. Uh, so add another page, sanity check. Oh, use some, yeah, that could be the same one. So let's do a sanity check. So under the microscope, there's a reset. Oh, there's actually a reset on here as well. So RST, where are you? So try to think what it could be. Yeah. Okay. So RST. What's the other one? EK, ED, ground. So ground is black. Black. ED is SWDIO data. Yeah. EK is SWDCLK, and this is reset. So knowing this, I should be able to connect it. So which means, what is it? Black for ground, which is the middle one here. And then there's IO. Oh, I need to. Okay. The ID behind this is that I had the color codes to left. So a reset. Put it down a bit. So that's green. This is white, purple, and black. So white is clock, and clock is the top one. And then there's IO. No, clock. White is clock, and data is IO. Yeah. And there's the green one, which is the reset, and the reset is on top. So this is connected now. So connected. Oh, my luck. Okay. Connected to Kali. See what happens. Where's my Kali? I'm now fed up with it. So STM microcontrollers, USB settings, add device, STM. Okay. Okay. So connect to it does not work, and it does not work because I did not have the device powered. So where is my power? It is here somewhere. Yeah. Try it again. And this isn't working as well, which is odd because this used to work. So why isn't this working? ST-Link, init failed. Unable to connect to the target. So if I remove the reset pin and try it again. So disable the power, reconnect it. No. So is it maybe that I have a crappy ST-Link? Do I have another one? Do I have another one? So disconnect this, use the other one, and have this one connected, and this one connected. Okay. This is showing different stuff. Did I see this before or not? Listening on port? No. Um, do I need to turn the device on, maybe? So what could be the reason that this is not working? Sorry for not showing you what is happening around here, but these are the glasses that I connected to the ST link that's over here. Show dashcam. So glasses connected to the ST link. What I could do is connect it to the Raspberry Pi, which is a physical machine. Reset. So open the connection to the Raspberry Pi. Where are you? Stuck? No. Okay. Reset it. Okay. Restart session. Oh, sorry. Wrong one. So waiting for the Raspberry Pi Zero to boot. Come on, you can do it. Yeah. Sudo -I. Okay, I have a connection. LS USB. And I found the ST link. Okay. Is OpenOCD installed? No, it is not. Opt get install OpenOCD. Yeah, sure. Go ahead. Look at my cool B-sides Newcastle glass. Ah, lovely. Okay. So OpenOCD is installing on a Raspberry Pi Zero. So using it both for the canbus shield and for the JTAG. Wrongbout on Twitter has like an awesome setup of using the Raspberry Pi for multiple stuff, like his all-in-one weapon of choice. So OpenOCD, yeah, this is working, not the correct one. So I need to open OCD-F for what is the first config file name, and the first config file name is hello? Oh, Target is the ST, no, is the STM 32F0XCFG. If I learn to type, and the other one is that I need, oh, Control F, right click, Control F, right click, and this is not a target but an interface, and this is the ST link CFG, I think. Oh, V2. So what did I do different than the other one? So the other way around. Okay, yeah, okay, can imagine. So interface stlink.cfg, and the other one is stm -fulus. Open OCD in procedure script. Can't find interface stlink. Why not? Oh, this is the old one. Oh, there's different ones on my VM as on, is it V2 maybe? I think it's V2.1-1. Let's try it. Version 2. Yeah, that looks correct. Enable to connect to the target. So if I turn this on or off, try it again. Oh. So what am I doing wrong? I really have no clue. At least my reset pin is flaky, so let's see if we can fix this with another cable. So, enable, so if I boot the device, okay, let's do it differently. Let's not power on the device and add a VCC pin. So where's the VCC on this one? It's underneath here, and I need a male. And connect this one. So boot it. What if you just run OpenOCD? Okay, OpenOCD. No, it needs a configuration. So people have done this before. STM32 OpenOCD. GTB. maybe, oh, open OCD, dump firmware. So the that would be too convenient. So flash, this is actually flashing the stuff. That's not what I want. I want to firmware dump. I don't recall doing it like this. Interface, target. I can at least try this. So it's an F0. Oh, but now it's not powered, so I need to power it again. So what do we get when we look for open OCD plus the ST-Link file only? Okay, sure. No, I need a transport. So I need the ST-Link as well. Oh, only the ST-Link. Okay, yeah. Okay. Adapter speed is not set. Configuration. Configuration. Adapt. Making a mess here. Dash C. Adapter kilohertz. Adapter kilohertz 3000. Transport select. I should make a proper config file. SWD. JTAG. Let's create a proper config file. Open OCD config STM32. Yeah, that's the normal one. Oh, hold on. No. ST-Link F0. And this is run from the directory itself. Locate open OCD. That's an exe. Which open OCD. Use a bin mod. Okay. Yeah, thanks. That is a targets. It's the wrong slash. No. Yeah, still going strong. What I actually could do is I made some video footage of this one, like do a streamception again. So www.youtube.com/Jillis_no Jillis.com. Oh. So figuring out, and this is maybe some proper ones. Cloning. NFC. Programming Atom. No thanks. So was together with Chrissy maybe? JTAG, yeah. So actually I did JTAG. And so that's the continuity setting. So streamception. So I now know what pin 1 is. Not going to do with my hand. So where's the JTAG? Screen. Oh, this is EEPROM. Can I set this? I saw CISP. Okay. In the code. So yeah. Okay. So the board as well. Should be here somewhere. So do I already dumped the data. So go back. So that's ST. This is something different. Where's the glasses? Yeah, it's this one. And if like the old EEPROM.
Yeah, just run mine now.
Yeah, glasses.
To open OCD to.
Okay, open OCD. Am I able to? Yeah. And can I take another one? So what I did was I used the ST-Link V2. Hello. Oh, it's this one. Okay. Go to this. Oh, a 666 and a 444. So what did I do at that time? Open OCD, scripts, interface, ST-Link. I did something else. Oh, I was using the NRF. Oh, this is stupid. This is utterly stupid. The glasses are no STM32s. The glasses are actually NRF 5.2, I think. Let's look at the stream itself. Where are you? So NRF 5.1. Yeah, 5.1. CFG. Come on, you can do it. Okay, so add some power to this. Where's the power? So this is 3.3 volt. So connect it. No, it's not working. So I'm not using this one, I'm using the USB power to connect to it. So connected. Turn it on, use the power button. Where are you? Here. This is so odd. So why isn't this working? I/O. This is the Raspberry Pi. Respect for the 7 people that are still in this stream. Not giving up. So Raspberry Pi still here. LS USB. LS USB. So back to the stream. Do I have?
So let's do
The wiring.
one. Okay.
Okay, cool. Okay.
To voltage, and I'm using one of the pins. So I took white. White is clock. So connect it to the clock. And now I look at the reading of the multimeter up.
Got the ground, yeah, I got the ground. So ground's the black one, and ground is.
I think I can better show you like this.
Oh,
3.09
I'm so stupid.
volt. So on the clock it is 3.09 volt. So now
Clock
I'm
is
going to the data,
white.
which is the purple one.
Oh, I'm so stupid.
So connect it. It's also 3.09 volt. And
So what I did is I swapped pins around. Assumption is the mother of all. Hey, it works. Okay. So let's see if we can dump some firmware. So what I did is I swapped the clock for the ground, and it won't work if you do that. So this is one. Need to connect to another one. Oh, I can probably connect using PuTTY. Where are you? So PuTTY. And I have in my OneNote the IP address of this device. Where are you? Hello. Oh, it's over here. You cannot see it. You can now. So this is the 106. Copy. So 106. Yeah, you can wait for a long time when you do that. I'm glad it is not broken yet. So guess it's not 444. PuTTY. Telnet. It states what port it is connecting to, right? It used to do. Above here somewhere. maybe on the other one. So telnet connections 444. Okay. So see if I can create a telnet connection. Putty telnet 106.4.4.4.4. Open. Connection refused. So is there like a firewall? IP tables -L. No, does not seem like it. Maybe just connect another setting. Yeah, localhost. Yeah, I thought maybe I can connect to the device itself, running on all the ports, but it's only on localhost. So connect this one again. Connect to the Raspberry Pi. Okay, where are you? Come on. 106.22. Yeah. So this is my secondary screen. So log in Pi and go to yeah, sudo -i telnet localhost 4444. There's no telnet. So netcot, missing port number. Oh, without a P. Okay, on chip debugger. So help. Yeah, works. So let's make this a larger screen. And where am I? Control D. Control escape. Escape. Oh, no, let's not do that. Help. So I am in root ls. Okay. Netcat dump. What was it again? Help. So something. Was the NRF dump firmware? No, it's generic. Use its weight transport phrase test. Target. Soft reset. Reset profile program. No, we're not want to program it. No init, none. JTAG. Load image. That was dump image. So this must be up. ARM. Dump image. File name, address, size. So that's dump. How do I write dump image? Underscore image. Image glasses.bin. Started at so and do this for whatever. I probably should have lost a 0 at the end, so it's taking more time than it should. Okay, so quit this one. Control D, Control C. So, okay, so where did I write that? Locate glasses.bin. Update DB. Oh. Opt get install and locate. Lazy. Yeah, I either use that or I use the DU. So if it's not installed and I don't want to install it on the server, I use find or DU. Like if you do a DU slash dash grep glasses, that would do the trick as well. Should do the trick on a slow Raspberry Pi Zero. Let's stop this. Update DB. Locate glasses. Okay, oh, it's an OpenOCD. MV OpenOCD to, yeah, trust is all. Strings, glasses. So this is like the firmware of this device. So we now have a working ST-Link. We have a working OpenOCD. So let's go for the next one. So I need to connect the wires to the CTF thing. Let's shut down the glasses. Yep, down. So where is the board itself? So the board itself is here. So going back from 0. So this is the ground. Pin 20 is the ground. And the ground on this baby is not in the middle, but in the middle here. Yeah. Thanks for the heads up. I really value that. And now go to devices. So JTAG, pin out. So the reset pin is on pin 16. So there's 20, 19, 18, 17, 16. So there's 3 in between, yeah. So this is the reset pin. So let's connect this to reset. Reset is top left, okay. Furthermore, I have a STD-IO, and STD-IO is from the bottom. So there's like 20. So 20, 19, 18, 17, 16, 15 is IO. So IO is the top one. So this above ground. So I need another wire. And this is clock, which is above. So connect that one. And it is underneath the ground. So connected. So let's so where is my so this is 2 connections. So this is the first connection. This should be set to so this is the Kali. So we're not using the Kali, we're using the other one. So this is a Raspberry Pi, so connect this one. This is not using an NRF, but this is using an STM32F0x.CFG. So not working yet. So I need to power it. Okay. So why isn't this working? The reset pin is connected. STD IO, STD clock is connected. Let's validate whether this still is an STM32F0. So open the OneNote again. So STM32F0, STM32F0X. Yeah, sounds legit. So why isn't this working then? Scroll back. So interface target. Yeah, it's a 48 pin target. So 12, 12, 12. Target. Let me see what I did. Pin 13, PA13, PA13 is the third from the top. So let's disconnect it and validate it. So it's disconnected. So connect the wire to it. Male, female. I was saying it was like 1, 2, 3, 4, 5, 6. So IO. Let's combine some stuff. X pin out board. So 1, 2, 3, 4, 5, 6. So this is IO. So if this is IO, where's the red one? Need to connect a wire to it. Pin 34, and the dot is aligned top left. So go to the board. Pin 34 is the third from the top. So zoom in on the microscope. microscope. So third one from the top. So which is this one? Assumption PA13. Okay. Select. This one is connected to the red one. Why not? PA13, top 13. So it's damaging the 13. Well, yeah. Then I can like measure forever. Top one. Why is there? Follow the traces on the backside, yeah. On the left. This one. Go to the right, yeah. Okay. PA13, PA13 is SW212. Where's my connector? So this one. So it's 20. 1, 2, 3. It's 20, 19, 18, 17, 16, 15, 14, 13. 13. 20, 19, 18, 17, 16, 15, 14, 13. 13 then. So let's validate that. Okay. So the other one is PA14, which is on the top. So let's leave this one here. So this is IO. And another one. This one. So is it like next to it? Just try it. Okay, so should be top. Where's my microscope? Little trace going from the right to that most pin via, yeah. So that's the PA14. So that's this pin. This is the, where's the via? No, it's underneath. So this is actually the via. And now so that's underneath. So this 1, 2, 3, 4, 5, 6, 7. That's PA 14 on, no, PA 14 is SW2. Oh, how convenient. That's pin 14. It's the same. Okay. So there was another pin. 14, 15. But that's what I just measured. So port, no, it's 13 and 14 instead of. That's where I pin 7. Okay. So This is the I/O and this is the clock. So this one and the other one should be pin 16. It's from the ground. 20, 19, 18, 17, 16. Connect a wire to it. So this is, and now this one should be pin 7 for the reset, which is 7, yeah, on the left side. And I think there was a fan out next to it, being this one. So that's correct. So I missed one. I swapped one connection. So although I tried to document it. Okay, so this is the ground. So ground first. And then the purple one is the I/O. The yellow one is the reset. And the blue one is the clock. Okay. So now connect power and run the Raspberry Pi. Works. Thank you, Killer Geek. So have to connect one. Yeah, works. So now open up a another Raspberry Pi thing. 444. Where are you? Okay. So already did a dump here. Oh yeah, so, sorry for not showing the screen. Yeah. So there's a dump image in here that no, never mind. So where are you? Everything's still working. Raspberry Pi. So that's dump, maybe halt. The reg, yeah, dump image hardware io.img. Something like that. Okay, done. Control C, strings. I need to copy it. Did that before. So it's probably in the same folder. Hardware io.img. Strings. So hex editor. Hex dump. Hardware io.img. It's not ending with zeros, meaning I did not dump enough. So connect to it again. Dump image. I should probably hardware io.img ox. Okay. Should probably look at the data sheet to look at the amount of data that is available for dumping. That would be a better idea. 120 kilobytes of flash, which results in what hex value? I'm running Windows. I have a very special calculator for this. 128 times C. Oh, my batteries are low. How can I add some power to my headphones, which just a minute ago still had power for 9 hours? Yeah, do I have power? Decimal 128 times. I don't know what I did last time. Okay. So the correct value is 2 and 4 zeros. So maybe I should stop this. Dump image hardware io.img ox 2234. Okay. Yeah. Let's use that as a start address then. Oh. So it's dump image hardware io2.img. Okay. Oh. Now it actually tells me that it's dumping. Ah, okay. Makes more sense, and this is actually 128 kilobytes. So let's quit this one. Strings and copy the file. Hey. Pin map mismatch. Nothing to see here. Doing obfuscation, doing bullshit. So those are the things that we saw earlier. Yeah. So no yord equals yord name. So this should be Score! Yeah. So you see, like, some persistence is really helpful. We have seen those in Ewart, actually. Yeah, we did. There's nothing on, so it's like bullshit. Cannot initialize UART. So I do not see any flags here, nor do I see any references to canbus. Next thing would be to load this into Ghidra and like to decompile stuff, but it's already getting nearly 12 o'clock. So yeah, let's save this one. And we might continue. Yeah, hacker voice, we're in. Yeah, cool. This was a lot of fun. So I'm going to like make some notes on the correct pins and not have them with an offset one. And thank you very much for attending the stream, especially Killer Geek for pointing me out that I need to reevaluate the correct pins to find it out. But this was a cool experience. Learned a lot about Ken. Learned a lot about STM and the other stuff. So what I actually should do is fan out all the connected pins on the board itself to the individual STM pins. Maybe not do those live on screen, but do these before the stream. Yeah, thank you for sharing, and I was like really grateful for Ian to be in the stream. I met him only on Sunday, and he's such a kind guy. Was so helpful and like sending me stuff that will arrive today for building my own canned gadgets. Yeah, so really grateful for that. And it was actually been initiated by someone else that saw my shout out on Twitter and connected me to Ian. Just the same as Jovsek that connected me to Xavier for pointing out that this batch actually had for firmware since it was blinking. Hey, oh, since I halted it, it is now on a steady red connection instead of a blinking red and green connection. That's also cool. So maybe connect OpenOCD to GDB and have some fun. So yeah, a lot of cool things to continue on. Was a cool stream. Thank you very much. It was again. Is it still recording? 3 hours and 40 minutes. For some reason, we cannot have a short stream. Okay, thank you very much and good evening all. Signing off. Bye bye.